And if you want to add anything else about yourselves before start, because
I actually don't have much to say about myself, and WMO, I think, will go very quickly.
We are presenting first of all the organization, not ourselves.
Exactly.
Okay, so Pablo, you can begin.
Okay. So welcome everybody. Here we are today in another IAPS, a distance session. We've been covering lots of different topics in different physics fields during the last 4 weeks. And today we're talking about climate sciences and environmental physics. So we have here today Sylvie Castonway and Alexander Baklanov, which are members of the World Meteorological Organization, and will tell us about their work in the organization, how it works, and so on. So, and the first speaker is going to be Sylvie. She's an energetic, insightful, and responsible public communications manager and team leader. She has 25 years of communications and leadership experience in the United Nations system and in the private sector. She has been with the World Meteorological Organization since 2012 and is in the organization's editor-in-chief responsible for public outreach and communications. And then the second speaker, Alexander, he's got a PhD in physics and mathematics in the area of geophysics. And he's a doctor in physics and mathematics in meteorology and climatology. And he's been a professor in meteorology since 2008. He's a science officer of the Science and Innovation Department of the World Meteorological Organization. As I said before, he's affiliated as a professor at the University of Copenhagen and editor-in-chief of the Urban Climate Journal. He has more than 30 years of experience in environmental and atmospheric research, in particular in developing a new generation of online coupled meteorology chemistry models, especially for urban applications. He has published about 400 scientific publications, including 15 books and more than 200 peer-reviewed papers. He led a number of big international research projects for urban meteorology and environment, for example, FUMEPEX, EnviroRisks, Megapoly, and UMedChem. So having said that, let's let them talk about the World Meteorological Organization. You can start, Sylvie.
All right. Let me start by sharing my screen with you. Hello, good morning or good afternoon, depending on where you are. My name is Sylvie Castonguay. I work in the Communications and Public Outreach Department of WMO. I do exactly what that says, public outreach and communication. So which also involves dealing with the media and all of the events of WMO. So we do a lot of presentations to schools and to young people who are starting their careers. And our presentations are aimed at encouraging people to take up a career in our area, meteorology, hydrology, or climatology, and to introduce the organization. So we do have a video for the introduction of the organization that I'd like you to take a few minutes to watch, and then I will give you some of the basic details about where we are, who we are, and before moving on. So here's the video.
meteorological services in each country to provide weather forecasts and alert their citizens to dangerous tropical cyclones, heat waves, and floods through climate services. Thanks to scientific progress, climate services can now predict future climate patterns that
Okay, so that gave you a brief overview of what we do. So WMO is headquartered in Geneva. We're a specialized agency of the United Nations. We work with national meteorological and hydrological services of 192 member states and territories. Territories include, for example, the Caribbean region. Member states are what you know as countries. So to join the WMO, one has to deposit an instrument of accession, which goes through a parliament, and it then is deposited with the United Nations, and you accede to WMO. You're the head of, usually the director of the Met Surface sits in the WMO assembly, which you saw in the videos. That was the big conference room. It's similar to the United Nations Assembly. So at this Congress, we call it our Congress. Members get together and they decide on the goals and objectives of the organizations, assign a budget so that the organization can deliver on the goals that have been that they have agreed on. And then over this assembly, this Congress meets currently every 4 years. We may start having every 2 years because there may be an extraordinary session in that 4-year period from now on. Every year we have a smaller group that called the Executive Council. It's about 48 members that meet to make sure that we are working towards those goals and where we are along that line, and generally monitors what the organization is, that the organization is achieving its goals and where corrections need to be made and adjustments done. And that's the general functioning of the internally of the organization. And so WMO is a coordination mechanism. We help the members set standards and then implement those standards so that data, observational data, can be collected and exchanged worldwide so we can get better meteorological observations and better and comparable data that can be used by all members to give early warnings, to monitor climate change elements and hydrological events such as floods, droughts, things like that. So we coordinate all of that and facilitate the implementation of all of this, the whole system behind that. So we are headquartered in Geneva. We have about 300 staff. Currently, we've been setting up regional offices over the last few years. We have one in Singapore, one in Ethiopia, one in South America. Geneva acts as their European office, so there's basically one for each region. And then we have some smaller project offices, but most of our staff, I would say 90% of our staff are in Geneva. Our regional offices only account for about 10% of the organization staff. So most of the work does get done in Geneva. So we are the UN's authoritative voice or scientific issues relating to weather, climate, water, and atmospheric environment. We usually do all of the climate events. We report on the latest observations on greenhouse gases, on the state of the climate. We coordinate with all of the UN entities that report in those areas. We also work with the disaster risk, UNDRR, which is UN Disaster Risk Reduction Organization, because 90% of disasters worldwide, relate to weather, climate, and water. And due to climate change, those events that end in disasters and destruction of homes and infrastructure and the loss of lives are becoming more intense and almost very difficult to mitigate. But we work toward, this is one of our objectives, to work towards this, and we work very closely with UNDRR on that. We work closely with all of our emergency organizations on getting early warnings out earlier, better, clearer, with impact-based. Instead of saying you'll have 100-mile winds, we say what the winds will do, so that people can understand what's going to happen exactly, and what action they should take and make better decisions to save their lives. So we've changed our work from a very scientific approach to getting closer to the end audience, which are in the general public. I think with that, I will now move on to my second video, which is on why you should all consider, as students taking, especially as physics students, taking a career in meteorology, what it contributes to, because even if I spoke for half an hour here, I could not contribute and let you know how many areas are actually influenced and how important it is, the work that we do. So here's the second video, which will help give you a better view of that.
When should I wear? When should I plant my crops? What policies do we need for adapting to the impacts of climate change? From our most mundane decisions to some of humanity's most challenges, almost all of our activities.
Sylvie, we're not listening to the video. We see the pictures, but we can't listen to it. So let's see if
the sound is not coming through?
No, it's not coming through.
Oh, I'm so sorry. That's That's odd. Did it came through on the first one?
No, it didn't either.
Oh,
I thought you had a problem and you couldn't turn it on.
Also just
No,
wrote
because
about
I
this problem.
I have it here, so I assumed you had it. Oh, sorry, you should have told me.
I'm sorry, I should have told.
Let me just see if I can. That is too
But
bad.
most meteorologists and hydrologists
When I make it
are
louder,
Now,
does it?
now it's okay.
Oh, should I start over?
Yeah.
Sorry about that. You should have told me before.
Now put it louder again.
Since ancient times, nearly every culture on Earth has studied weather and the changing seasons. Today, advances in science and technology allow us to gather detailed observations using a host of modern measuring instruments. Some of the most powerful computers in the world are used to run sophisticated models of how the Earth's atmosphere interacts with the ocean, the land, and the water cycle to produce our weather and climate. Translating all of these results into meaningful information requires a large number of skilled and well-trained meteorologists and hydrologists working around the world and around the clock. Thanks to the dedication of these passionate individuals, policymakers have access to high-quality forecasts and advice that they can integrate into national planning and decision-making. Information supplied by meteorological experts is also valuable for key sectors of the economy, from shipping and air transport, which rely on forecasts to maximize efficiency and reduce risks, to tourism and recreation, which depend on weather forecasts to plan outdoor activities and keep people safe. In the agricultural sector, meteorologists assist farmers to plan optimal timing for planting and harvesting of crops based on seasonal conditions. They also provide crucial data and forecasts to the energy and water management, structure, and boosting the use of renewable energies. Meteorologists are central to national efforts to promote public health and safety, from predicting outbreaks of air and waterborne diseases to issuing early warnings when a dangerous storm or flood threatens to harm people and damage property. National militaries also rely on forecasters to protect their troops and equipment and plan their strategies. Perhaps the most recognizable face of meteorology is the weather presenter. These professionals have both the knowledge and credibility to engage and educate the public, and they play a key role in alerting people to extreme weather events. But most meteorologists and hydrologists are rarely seen by the public. Working with sophisticated equipment, they tackle complex issues ranging from keeping airplanes safe to reducing urban pollution to designing climate change policies and works to drive socioeconomic development and promote human welfare around the globe.
Okay, I'm very sorry that if you couldn't hear that. I didn't realize there was a problem with the sound since it comes in through clearly here. Did everybody, was that okay in the end? Okay. Not sure you're hearing me at all.
Yeah, it was in the end, kind of, but I mean, the sound just faded away sometimes and then it came back.
Well, that was just to highlight, the video highlights
Mm.
basically how meteorology, climatology, and hydrology are present in every area of our lives, from traveling, from the even if you are not in an industry you think is unrelated, it is necessary. If you have to transport goods by ship or by air, you need meteorological, you need forecast, sorry, a weather forecast to optimize your routes, to save energy so that you're not wasting as much energy. The whole energy sector is completely dependent on weather climate information. Agriculture is dependent on climate and long-term forecasts. So, and we really encourage people to consider a career in this area because it is fulfilling. You can make a difference to not just your area, your country, but internationally now with the growing importance of addressing climate change and mitigate and finding solutions to these problems. So I encourage you to think of it and maybe look on our WMO YouTube channel for these videos. If you weren't at all able to hear them, I'm very sorry. I didn't realize there's a technical problem. I usually do this on my Mac and I'm on my PC today, so I don't know what went wrong. So I apologize, and I'm available for your questions for another 15 minutes, or I can answer afterwards if they're sent to me. Thank you very much for your time and attention.
Okay, so let's see if we've got any questions in the YouTube live stream. And so as you're leaving early, I think we can make some questions to you just right now and then go on to Alexander. So as climate sciences are becoming increasingly important in our societies, what role do you expect them to play in the short term and in the long term?
So there is a challenge right now to find ways to mitigate emissions of carbon. It is a huge challenge, and so far there are no real viable solutions for the amount that we are actually dumping into our atmosphere. And climate change has been quite slow because the oceans were absorbing it, but the oceans will soon reach their limit of how much they can absorb. So the societies will have to adjust to the new climates, to the changes that will come. And there will be great demand, I see, both in the short and long term, for people who can address these questions, who can give governments guidance, who can help companies to decide how to evolve and which choices to make in developing new businesses and the directions they take, and how they even the logistics of delivery and energy, because most industries are energy intensive. So I think there will most definitely be a long-term need in this area.
Mm-hmm. And now let's go for a more personal question. How did you get involved in the World Meteorological Organization?
Okay, so I am a communications expert. I am not a scientific expert, although I did do 2 years of science in college before I decided I would rather work more closely with people. So I changed to business studies and did communications. I started in the UN working with the World Intellectual Property Organization, where I worked in, which is trademarks, patents, and creativity copyright. And did a lot of interviews of very famous people, of new inventions and patents, and it was actually quite interesting. But I thought I really wanted to work in an area that was, I thought, where I could contribute more. And when I got to know a colleague at WMO, and she said, I would really see you at WMO because you could, they're not good at communication. The scientists are not natural communicators, and they need your help. And you have such enthusiasm. Why not go there? And I must admit, I was hesitant at first because I thought, wow, talking about the weather? That's going to be a career, talking about the weather. I just saw the limitation of talking about the weather. And in the end, when I actually thought, okay, I'll give it a try for a year. And I got the job and I thought, I'll give it a try for a year. And actually, it's not about talking about the weather. It's talking about so much more. And yes, it does. Although I had been thinking of going to a humanitarian organization, this area to me is much more important, much more interesting, and so much needs to be done. I have no regrets. I've really enjoyed, because most of these scientists are enthusiastic and very concerned about the public good and working with people and seeing how they can help and change things and creating more awareness of where we are, and those that work in climate especially, and those in weather have dedicated their lives to improving early warnings so that people's lives aren't lost in disasters, that countries' economies aren't set backwards because of being a catastrophic event like a hurricane or a long-term drought in which thousands, millions have starved in droughts. Droughts are terrible. I mean, as a child, I remember seeing all these television shows where they'd be always trying to encourage you to donate to people in drought. And I had never made the link, sincerely, that this was the organization that worked on these things. I could understand the organization's humanitarian feeding the people, but I didn't make the link of, well, before that happens, somebody has to give an alert that a drought is coming and these things are happening and take preventative measures. Then you can maybe not end up in that situation. So I'm actually very glad that I ended up here, even if it came by a circuitous route and it was somebody else pushing me. She was retiring from WMO and was really pushing me to apply to take her place and kept calling me about it. And she's the one that ended up winning this because she's definitely right. So that's how I ended up at WMO.
So as you are part of the communication staff, have you experienced an improvement in the or a significant impact in the media of the World Meteorological Organization? Has it become known more than it was a few decades ago?
Most definitely so. We keep statistics on it, and I'm impressed at how much more we are covered in the news, how much all the big media contact us now for interviews. The WMO is often covered, maybe Al Jazeera, BBC, the BBC, American channels. We're always calling our colleagues for asking them if they can do interviews. It is people, and I think the public is convinced also by climate change, much more than they used to be. This polemic, it's rare anymore that anybody goes on. There are doubters out there. There'll always be doubters. I mean, there are people who doubt the world is round. They think it's flat. So I'm not saying we've convinced everybody, but there has been a huge change. And we do see the statistics that in our coverage and how much media we get, how often we appear in the news, the followers we have now on social media, that the interest has really skyrocketed.
So as you've said, public opinion has changed. public opinion over the World Meteorological Organization? And what about governments and policymakers? Are they listening to your advice, or are you having an impact on them?
We report the scientific facts of what's happening, and we really stick to the facts. The UN organizations like UNFCCC, the United Nations Framework on Climate Change. Sorry, they are trying to develop policy. So we always make presentations and join in their message on developing that climate change policy, on limiting the greenhouse gases, on moving backwards in emissions, instead of them increasing, maybe starting to decrease. And we join in that. And I think, governments have heard the message, many are adjusting. Of course, governments deal with other problems. Right now, there is the huge crisis due to the COVID, and they have to find a balance and equilibrium in trying to deal with these problems and other problems. Sadly enough, one does not make the other one go away. If because of COVID, climate change wasn't happening anymore, that would have been an easy answer, but it is for them a very, very difficult thing to address, especially as it's long term. It's a political term, it's 5 years, but climate change it's going to take the next 50 years of people acting in accord to address this problem.
Mm-hmm. So if you want, you can stop sharing a screen.
Oh, I think you had to stop it, you told me.
Oh, yeah. Yeah, sure. So, yeah, that's it. So we can discuss more comfortably. And here goes a more specific question. How do you, as an organization, so a scientific organization, deal with misinformation and disinformation regarding environmental issues, such as urban pollution, climate change, and so on?
Yeah, so this organization, we try to keep our focus on the science. And we think as long as we keep trying to put the science out there and stick to the scientific facts, not get caught up in all of the other issues that are out there, the development of policy, but stick to our core competence, which is really the science, then we think that our message is clear. And this is the only way we have of debunking people who are putting false messages, in that we remain very clear and scientific and factual about our messaging.
I think it must be very frustrating to see how all that scientific work that's been carried on for decades now, from nowhere, from groups of people in social networks, it's being thrown away and disregarded. I mean, Alexander, maybe you can say something about it. How do you feel when you see misinformation on social networks and so on, as a scientist?
Of course, as Sylvia already mentioned, we worked with our scientific community, and in our working groups or science advisory groups, what we build for specific problems, we invite best scientists around the world. And of course, if we get some information which are not based on scientific knowledge, usually we ask our experts to provide opinions and conclusions for such issues. So at least our recommendations from the WMO are usually based on best scientific knowledge and not proceeding from some low-level information of this used in internet, etc. So at least it's trustable. And Sylvia is one of the our colleagues who are responsible for this dissemination issues.
Mhm. So I think we can now start with your conference, with your talk, Alexander. Thank you very much, Sylvie, for your introduction and your comments about the structure of the World Meteorological Organization. She's going to leave early, just to
Yes, so thank you and goodbye. If you have any questions about the organization, you can always contact us through our website. We'd be happy to answer your questions. Have a good day. Bye-bye, everyone.
Bye, Sylvie.
Thank you, Sylvie.
So now, if you want, you can share a screen.
Okay. Can you hear now and see the screen?
Yes.
Okay. So I'm Alexander Baklanov, and Science Officer of the Science and Innovation Department of the World Meteorological Organization.
We've got a question from a partner, Neil Darren,
Okay.
about artificial photosynthesis, but I think we'll leave it for the end of the presentation. So keep tuned, a partner will answer your question later on. Sorry, Alexander.
Okay. So may I start now?
Sure.
Okay. So my lecture is more focusing on research priorities of WMO and specific research programs, and of course related to environmental physics. And practically all programs that are realized in the organization and with our members and scientists are linked with physics and environmental or geoscience issues, geophysics in particular. So at least for your specialization, expertise is very important for climate, meteorological or environmental issues and problems that are considered by the World Meteorological Organization. So I hope what you'll find interesting topics for your future activities and specialization in your university education. So just some outlines what I thought to briefly mention. Sylvia already mentioned about WMO task. I just remind about our missions and science innovation priorities and specific programs and the approach that now we realize, it's called seamless Earth system modeling and prediction approach and multi-scale early warning and Earth modeling systems, and also different approaches what we are realizing in specific research programs. In particular, I also would like to mention a bit about urban issues, because it is one of the priority and also a topic what personally I'm involved in the research department of WMO and other projects what we are considering. And of course, finally, I would like to stress that all our research programs are not just research for research, but the main motto, research should be working and providing input for services. So the main motto, research for services. The mission of WMO, I already mentioned it, it's specialized agency of United Nations, and now it's 186 member states and 6 territories are included, and the main strategic priorities now are considered as disaster risk reduction, global framework for climate services, and also WMO global observing system, aviation meteorological services, polar and high mountain regions, and capacity development, of course, and governance. Operational network of WMO includes several levels of observation, and first of all, it's WIGAS WMO integrated global observing system, and here on this slide you can see what all type of observations are included: satellites, land, ship, aircraft observations, and of course considered all types of parameters measuring temperature, turbulence, wind, and also atmospheric composition. We have also global communication system for providing this observation in online or near real-time data for forecasting system. So here on below in the central part, you can see here the global data processing and forecasting system, what we call GDPFS, which is providing a forecast of global and regional forecast of meteorological and also climate. Finally, it's moving, as I mentioned, it to service delivery for specific purposes and for different end users, and for, first of all, for our members. And of course, for the main center of WMO operational system is a prediction system. And here on this scheme, you can see how it works. First of all, we proceed from global society needs and moving to research activities where we need to build new knowledge and also observation and data exchange, and going to data processing and modeling forecast. And moving to outputs, first of all, weather service, climate service, hydrology and water management, also environmental service, and some research analysis and findings. And finally, it's going to social benefits. As I mentioned, these priorities of the WMO, and they actually are requested by the global society. And now we have also a very important period at WMO of reform, which was initiated by the last World Meteorological Congress in June 2019. And now the work of World Meteorological Organization focusing on 21st century requirements, and first of all for United Nations Sustainable Development Goals, what you can see from the right and left side, these 17 Sustainable Development Goals, and WMO is contributing to many of them. And now also a new structure in Central, you can see how it works for the new structure after the reform. So main directions is disaster risk reduction, sustainable development, and mitigation adaptation from, of course, climate, weather, water, and environment services. And what is important, as you can see on this on the top, now we have a new scientific advisory panel and also a research board for analysis and development of research programs, and focus on science and research activities and innovation is much stronger, and it's one of the requirements from the World Meteorological Congress for the future activities at WMO. And just proceeding from previous priorities, which was initiated by the Commission for Atmospheric Science of WMO, and the main challenges were specified. First of all, urbanization is one of the first topic of priorities, and also high impact weather. You know, now it is a really important issue, and more became more important with effects of climate change. And water and aerosols are also in focus, and especially interaction of weather and climate with aerosol and atmospheric composition. And finally, new technologies and greenhouse gas information system. And in general, these four main challenges required new approach for realization and what we call seamless prediction, considering all elements of the Earth system and also different disciplines. What we call weather enterprise value chain, including monitoring, observation, models, forecasting, dissemination, and communication, and also perception of different risk and interpretation. And finally, decision-making and user products. This for deliver this weather information from minutes to, sorry. For practically forecasting from minutes to months, and also from global to local scale. And following these priorities, what I mentioned, it briefly came through them. First of all, high impact weather, and it is mostly within World Weather Research Program considered and required for further improve of prediction of high impact events, wide range of scales, starting from nowcasting for next hours, and for long-term prediction as well for seasonal or sub-seasonal. And we have a special high impact weather project initiated several years ago with special attention to hydrological consequences of extreme weather and to resilience of the urban environment. And another priority is water and improved disaster risk reduction and resource management. Previously, models for atmospheric modeling or ocean modeling were not fully coupled. And now the new approach, what I mentioned for Earth system modeling and prediction, required seamless coupling of different elements of the Earth system. As you can see here, ocean, land, and sea ice, and also atmospheric chemistry with atmospheric dynamic. So this one of the priority, how to link with hydrology and with water processes and with oceans. This one of challenging tasks. Another priority is integrated global greenhouse gas information system. You know, climate change required us to put much more efforts on monitoring of greenhouse gas emissions and providing strategy and policy to reduce emissions of greenhouse gases, and also other type of forcing pollutants, short-lived climate forces, aerosols, etc. And this program is focusing on providing such modeling tools, including inverse models and also observation system. And a Global Atmosphere Watch program is focusing on this issue and work with this priority. And other priority is aerosols, and it is very important to consider, and in previous decades, maybe impact of aerosols were not considered as a priority, but now it is more and more included and understand what it is very important, not only for air quality, but also for weather forecast and also for long-term climate prediction. Because they are interacting with atmospheric dynamic and climate and meteorological processes. And of course, they have to be considered and also integrated with observation system. And finally, one of the priorities is urbanization, as I already mentioned it. Now we live what's called 21st century is century of urbanization. And now already majority of people on our planet live in cities, and percent of urban population will be increasing. And we have to care, of course, about sustainable development of cities, and climate and environmental aspects are very important for sustainable development. So this what WMO call it cross-cutting coordination of urban issues, including weather and climate, and also environmental aspects. So if we'll have time, maybe we can discuss a bit later. And finally, evolving new technologies. Of course, it is very important, and we put special attention for non-conventional observations. Now there are some new type of sensors, let's call it sometimes low-cost sensors. Not always they are really low cost, but at least new technologies provide much more sources of observation, and we need to learn how to use and analyze quality of such observation, because we cannot use information from sensors with low quality, and it could lead to wrong conclusions, and of course data quality control is very important. So of course it's also one of the important field for physicists, and different type of observation, and also how to assimilate such data to models and forecasting tools and systems. And also one of emphasize what is growing interest is geo-engineering. Of course, it is very sensitive issue, and we have to be very, very careful, because price of mistake could be life of the planet. So of course, it is very conservative, and based on best scientific knowledge should be done. And just a few words about structure of our Science and Innovation Department. As I mentioned, what we have a research board who are coordinating and providing priorities for research. And here in Geneva, we have Secretariat of WMO. It does not mean what all research programs are realized here. Practically, main activity are realized in our expert group and programs, which are led by best scientists around the world. So first of all, it is in different countries. First of all, our members, hydrometeorological organizations, national organizations, and also universities. About 70% of our experts in our science advisory group and working groups are from academia, from universities and scientific organizations, not only from hydrometeorological services. So of course, again, returning to your question about quality of recommendations what WMO is providing, it's based on best scientific knowledge. And we have three main programs. One is a World Climate Research Program with several projects, and a World Weather Research Program, and Global Atmosphere Watch Program. And correspondingly, the first program is focusing on climate research, second for weather research for shortest time scale, and Global Atmosphere Watch is responsible for atmospheric composition, observations, and also prediction for greenhouse gases, for reactive gases, and aerosols, etc. There's a structure how we work, and now I'll say more about each of the program and what kind of activities are realized. From previous slides, I suppose what it is clear for you that most of our research activities are based on physical science or other disciplines. But I have to say that now more and more we are moving from pure atmospheric physics and meteorology science to multidisciplinary research. And much more disciplines need to be involved. And one of the priorities and goals, for example, World Weather Research Program, what now on the slide, moving toward impact forecasting, not only physical processes, but for example, it's not enough just to forecast temperature or wind speed, or precipitation, but also we need to understand what kind of impact on social life or on economic will provide, for example, from high impact weather or from disasters, natural disasters. So this new trend, and of course, for these purposes, we need to involve scientists from other disciplines as well. But of course, main goals is moving, as I mentioned it, toward environmental prediction using integrated models, compounds with hydrology, sea ice, ocean, atmospheric composition for better understanding coupled processes and improving forecasting methods. So this moving to this seamless predictive capability and based on Earth system modeling. And here you can see some key challenges in numerical weather prediction in the future. So on the vertical scale, you can see complexity of models what are used, from simple flow simulations to moving fully coupled Earth system models, what I mentioned it, integrated different spheres. But from other side, resolution is very important. And if we are considering from turbulence scheme, which are scale of meters and up to global scale, where we need to provide also long-term trends with seasonal forecasting or prediction of climate for global scale. So it's different challenges, and of course, different type of parameterizations and coupling of models are needed. And understanding of physics is extremely important. And main research topics are focusing on understanding of different aspects of physical interactions. And correspondingly, World Weather Research Program is now considering several working groups. One of the working group for predictability, dynamic and ensemble forecasting, weather modification, tropical meteorology, data assimilation and observing systems, working group on numerical experimentation, nowcasting and mesoscale modeling and prediction. And of course, verification of models is extremely important working group. And also, as I mentioned, because it's a multidisciplinary approach, what we realize, also there is a socioeconomic research application working group. Additionally to these working groups, which are based on scientists from different countries around the world. We have also 3 key projects within the World Research Program for 5-10 years considered, because it's now in priorities. First of all, as I mentioned, high impact weather project, and another project from sub-seasonal to seasonal forecast, considering longer term forecasts, not only for 1 week or some days, as usually weather forecast is providing, but now it's also for a season or for monthly forecast. And the third project is a polar prediction project, is focused on Arctic and also Antarctic, where some scientific efforts are needed recently. And second program, what I mentioned it, Global Atmosphere Watch, or we call GAW program, is focusing on long-term monitoring of atmospheric chemical and physical parameters globally, and also analysis and assessments, and also moving now more and more to predictive capabilities. And we have different activities for this purpose. In particular for urban areas, or dust storm forecasting and chemical weather forecasting, and for greenhouse gases. And here on this sense, this nice flower, you can see the structure of the Global Atmosphere Watch program, and also it includes size advisory groups for different observation systems, for greenhouse gases, for reactive gases, for aerosols, and for a deposition of pollutants, and also for forecasting and modeling and prediction of atmospheric composition on different scales. We have special groups, and of course, considering satellite, aircraft, and land observation networks. We have more than 800 stations around the world from more than 100 countries involved. And as I mentioned, now in the GAW program, modeling activities is enhancing, and we are now moving to areas of atmospheric composition forecasting and atmospheric composition analysis and monitoring, and also for urban services with downscaling. So of course, it is also based on physical science and atmospheric physics. And some example of applications in the Global Atmosphere Watch. First of all, the program is supporting climate negotiation, in particular this IGES project for information greenhouse gas information system, and also for ecosystem services, for example, analysis of total deposition, nitrogen cycle, deposition to ocean, and marine geoengineering. Health impact, of course, is one of key element, and we are providing sun and dust storm forecasting and global and urban air quality prediction and biomass burning effects, etc. Food security and impact of atmospheric composition on agriculture, and transport security, for example, volcanic ash forecasting for aviation and also for land transport. And weather forecasting. It's also important, as I mentioned, aerosol effects of numerical weather prediction, and high impact weather is important element where Global Atmosphere Watch program is contributing. And of course, for all topics, we are focusing on research aspects where the knowledge is not complete enough. for forecasting of operational forecasting, and we need to put scientific efforts. And the third program is World Climate Research Program, and it includes several projects for cryosphere and climate interaction, ocean atmosphere, land atmosphere interaction, troposphere, stratosphere, and also considering ozone layer, stratospheric ozone, and also regional climate downscaling capability. And here, just for demonstration of importance of climate change, here see new records of greenhouse gas concentration for carbon dioxide, methane, and two here. And as you can see, from 1985 to nowadays, how they are moving. So, as you can see, no questions about what is happening. So, climate change is a fact, and you have to care about that, and policy to reduce greenhouse gases very much. And it is one of the most important problem what WMO is involved, together with, of course, other agencies and with our members. And again, for returning to science, new approach what WMO is realizing now for seamless Earth system prediction in these seamless frameworks. Actually, now we are not splitting as separate disciplines, for example, weather forecast or climate forecast. Time scale are now linked, and we try to provide Earth system modeling tools with different scales, starting from minutes and days and week, which is classical weather forecasting, moving to climate predictions for seasons and years, and for long-term climate scenarios and projections for decades and centuries. So, and corresponding Earth system models, new generation of models which is needed, should work for in seamless framework for such purposes. Just a few years ago, WMO published this book. It's a kind of our Bible with Earth system seamless prediction from minutes to months, and you can get this. It's freely available book from internet, and see the link where more than 100 best scientists around the world were involved in writing this book for different chapters. About 20 chapters are considered with main topics, with priorities of research which are needed for prediction of the Earth system. So if you are interested in this area, I think this book would be very useful for your orientation about scientific needs and maybe for your future specialization. What does it mean, seamless approach, and what kind of coupling and integration need to be considered? And this slide, you can see how its Earth system models are coupled with not only physical processes, but also with chemical, biological, and social as well. So, and it includes different spheres. So what kind of coupling we need? First of all, time scales. We need to consider processes from minutes for nowcasting until decades, and a climate time scale. Second is spatial scales. So in some processes, we need to consider meters and street scale and of course going to a larger regional scale and up to global scale, and also with downscaling and upscaling capabilities to consider this another challenge. And of course, integration of different processes, physical, chemical, biological, and social, as I mentioned, is also need to be considered, and it is an important research topic for online integrated models. And also Earth system compounds, atmosphere coupling with hydrosphere, pedosphere, and ecosystem and the biosphere. It's one more dimension of this seamless approach. But it is not only for different elements of models, but also we need to link observations with modeling tools, how to use data and how assimilate them, how to validate and make verification of modeling results versus observation. And also, of course, requirements for such observations is also a big issue and needs to put a lot of efforts for physical science. And finally, we need to integrate such forecasting system with users. It should be user-oriented and linked with impact-based forecast and services. So this approach, which required new generation of seamless models integrated with observations. So this new trend what is under realization of WMO after the last Congress, what I mentioned it. And it is a strategical goal for research programs of WMO. And another interaction is scale interaction. So one of example is nesting or downscaling from global to regional and up to street scale. And of course, it is very important for this seamless approach to consider global consistency and also consistency across the scale, and also some standardization of modeling approach. So if previously we used different models for different scales because parameterizations were dependent on scale, and now a new trend is moving to one model for different scales. Of course, it is much more time-consuming and with quick development of computing resources, we can move in this direction much deeper than it was possible in previous decades. And here just some examples, for example, for Copernicus service and European Center for Medium Weather, shortened medium weather forecast, and also atmospheric composition forecasting from global scale, moving to regional and to national, and it could be also downscaled to urban. And here you can see some examples of such forecasting. And below it's our system that was built by WMO for sun and dust storm forecasting. And here you can see over Northern Africa forecast of Sahara dust. It's also important problem. And another example how it's downscaled to urban scale, an example of our Indian colleagues for Indian megacities. They provide this chain of modeling capabilities from global scale and up to city scale, an example of Pune city with 1.5 kilometer resolution downscale. And other coupling is atmospheric processes interaction. This, I think, may be most interesting for physicists. Here you can see many different physical and chemical processes which are responsible for atmospheric dynamic and also climate and atmospheric pollution aspects, in particular interaction with clouds and with radiation and with different compounds of atmospheric composition, and also emission from industry and also biogenic emissions, deposition on the surface, and of course interaction with ocean and water. So these full processes need to be included in equations of the models what we are building, and of course they are quite challenging task because many of them are nonlinear and also providing chain of interactions. For example, temperature can affect on chemical composition and speed of chemical reactions, and chemistry is changing concentration of pollutants, and concentration of pollutants effect on radiation processes and reflecting or absorbing solar radiation, and it's change again to temperature. So it's a kind of a cycle of interaction. And of course, such systems, and you can see below many other examples of such interaction chains. Of course, it is impossible to provide such forecast by separate models for atmospheric pollution, for example, or atmospheric meteorological forecasting. They should be connected, and okay, it's one more example of these interactions what I mentioned. And here you can see effects of composition and meteorology is long type of processes what we need to understand and describe in our models. And of course, understanding of physics and microphysics of processes is important, for example, to describe interaction of aerosols with cloud droplets and cloud microphysics, and also with radiation. So in this direction, we are moving to coupled chemistry, meteorology, climate models, what we call online coupled models, when all equations are considered together with full feedbacks. And of course, not all issues are solved, and on the last symposium for this coupled modeling, several scientific questions were formulated, and here you can see still many questions are not completely answered, and it needs further research activities, and maybe it could be one of your topic for your Master Science or Bachelor of Science or PhD study. And you are welcome to read this report where these scientific issues are considered. Just some example of such interaction. Well, I think time is going fast, and maybe I'll need to shorten a bit. How aerosols are affecting. It's a nice example of dust storm over Egypt in Northern Africa, Northeast Africa. When our colleagues from ECMWF run models without effects of aerosols, they had this picture, and below picture is including only direct effect. Direct effects of aerosols, it means that interaction with radiation, or reflecting of radiation, or absorbing radiation by aerosol particles. When it's included, intensity was changed, and what is interesting, but it's provided again chain of interactions. Aerosol reduced flux of radiation to the surface. It's changed boundary layer turbulence structure and increasing what we call low-level jets and increasing wind speeds close to the surface and increasing speed of the wind over surface leads to intensive increasing of dusting from desert. So it leads to increasing of emission of dust particles into the atmosphere and correspondingly increasing of aerosol concentrations. So it's chain which is interacting in two ways. So it's one of the examples what we absolutely need to consider these processes with two-way feedbacks and all physics in models for weather prediction together with atmospheric aerosol dynamic and interaction with radiation and clouds. And when we analyze also indirect effects with the cloud microphysics, we understood what models showed quite different results, and really we need to improve models. And this is one of the issues which is not solved yet, and new generation models need to put efforts for understanding of these physical processes of interaction. So maybe it's one of the topics for your study. And also online coupling is helping for weather prediction and meteorological research for air quality or chemical weather forecasting, and also for climate and earth system modeling. So, and some main gaps, what I mentioned it, first of all, understanding of several processes like aerosol cloud interaction, which are poorly representative current models. Well, and moving just some example of projects, what I mentioned in the beginning. One of the key projects of World Weather Research Program is Polar Prediction Project, and currently it's on stage of year of polar prediction. It's called year of polar prediction, but it's for several years, and below you can see several phases of this project. Last 2 years it was very intensive measurement campaign in both in Arctic and Antarctic to understand also physical mechanism, how interact, for example, ocean and ice cover with atmosphere and feedbacks for weather and for climate system, and also including chemical species. And also it is important for climate, and especially because you can see here warming in Arctic areas is much higher than in middle latitude and other part of the world. It's actually 2-4 times higher than in other regions. So of course we need to put more efforts on understanding of mechanism over the Arctic and Antarctic. But influence of Arctic is also on mid-latitude. And for example, in warming climate, it's leads to change of weakening storm tracks and also increasing extreme weather events, not only over the Arctic, but also with feedback on mid-latitude regions. Other project, what I also mentioned, it high impact weather. It's important, and also due to climate change, it became more and more important. Considering, for example, urban floods and disruptive winter weather event, cold wave, and also heat waves, and wildfires, and extreme local winds. So this project is focusing on such kind of issues. And finally, I would like also to consider these urban aspects, what I mentioned it as one of the priorities, what WMO is considering. And WMO is also contributing to a new United Nations urban agenda with integrated weather, climate, hydrology, and related environmental services for sustainable cities. 17th Congress in 2015 required WMO to analyze and establish cross-cutting urban focus. And the last Congress is focusing on elaboration of integrated urban services and system. Why we need to put it? As I mentioned, of course, first of all, because urban areas are much more sensitive to natural hazards, and about 80% of urban hazards are hydrometeorological nature. So of course we need to put efforts on that. And it is including also poor air quality and extreme heat and cold events, hurricanes, typhoons, and wildfires, sun and dust storms again, and urban floods, sea level rise, and energy and water sustainability. And of course, everything is affecting also public health. And also we have to remember that actually climate change is also linked with urban environment, because more than 70% of greenhouse gases emissions are from cities. And of course, mitigation should also consider urban scale mitigation of reduction of greenhouse gases and short-lived climate forces. We have a special program, what's called Global Atmospheric Watch Urban Research, Meteorology and Environmental Project, focusing on such urban issues. First of all, again, models are focusing on urban features, urban pollutants, emissions, and land use drastic change due to urbanization, anthropogenic heat fluxes, and urban heat island effects, and also in homogeneities and roughness and heat fluxes and etc. You can see here many processes. And of course, it is also quite comprehensive physics of such interaction, and needs to develop a new type of models for urban applications. And also it's different scales involved in these processes. Here, you can see scheme of interaction of megacities with air quality and climate. And this interaction is also not only two, but many dimensions interactions, and also involving different time scales, not only city scales, but starting from local or street scales and going to regional and global, because urbanization also affecting regional and global climate and weather processes. But from other sides, we need to consider different time scale again, from second for understanding, for example, microphysics interaction and street scale processes, and up to days and weeks for forecasting of air quality or weather forecast, and years and decades for global trends for climate applications. And as I mentioned, processes are strongly non-linear, and again, with feedbacks between emissions, chemistry, meteorology, and climate processes, and needs to consider in interaction. If we consider coastal cities, it's even more comprehensive, because water is also involved, and interaction with water surface includes different scales for breeze circulations between land and urban surfaces and water, and also chemical interaction of species from seawater and atmospheric composition. So it's one more example of complex physical and chemical processes interacting for such issues. And returning to the priority, what WMO is focusing on this urbanization, the goal is to build integrated urban weather, water and environmental climate services, addresses urban hazards and risk. And of course, also there are several scientific issues what we need to put efforts. First of all, requirements for observations and how to utilize such observation for models and near real-time data simulation is also open question. Coupling of air quality, meteorological and surface processes in urban hydrological processes. And again, scale interaction. And also important issue to consider this street scale gray zone where not all parameterizations are suitable in current models for urban areas. So this challenging scientific task as well. We have many projects with pilot projects in different cities around the world, and here you can see some example of maybe you can find some your cities or your country's example, and welcome to join. If you are interested, we can connect with partners. And here one more example of our Indian Safar project system, which is realized. In the beginning it was for New Delhi, but now it's realized also for 5 cities in India. It started as purely research project, but now it's reached operational phase and use it for practical purposes. And you can see what kind of products and services from the left and right side presented. And of course, as I mentioned it, many open scientific questions related to urban integrated services still are open. And as you can see, first what I marked it by red color, most of them are physical science questions. And finally, all our scientific activities and projects, as I mentioned it, are working for services. So, for these purposes, one of the first slides I demonstrated, we have what's called seamless global data processing and forecasting systems, which are moving to operational, and our research projects contribute to this system and moving to operational services by our members, national meteorological organizations. And WMO has a number of different regional and global centers for forecast of specialized climate forecast and atmospheric composition, and for example, sun and dust, etc. And also you can see the global map where such centers are situated and with whom we are collaborating with our members. So just to finally say what it's important, what young generation is involving in this problem, and I suppose you understand perfectly what issues what the World Meteorological Organization is considered are extremely important for us, for our planet, and for citizens of the planet. And really, there is no planet B, and we have to care about our planet for next generations and for young generation, and it's in your hands. So welcome to join our activities, and I hope that you'll find activities of WMO and our members interesting, and you'll join meteorological and climate science, and you'll choose this direction in geophysics, atmospheric physics, and meteorology and climate. Thank you very much. And if any questions, welcome. So.
Thank you very much for your approach on this topic, this interdisciplinary explanation. It's quite complex.
Yeah, definitely, yes.
It's really, really complex. You need scientists from very different fields, economists, biologists, physicists, chemists. So we had a question from before, which is not really, it doesn't really stick to the topic, but let's see if you can give us a quick insight. The question is if artificial photosynthesis is a growing technology in the future, and when it comes to producing fuel for transport, which has, if it does have a minimum environmental impact, fuel which comes from artificial photosynthesis. Do you understand the question?
What do you mean artificial photosynthesis?
Sorry?
What artificial photosynthesis is considered? Not clear for me.
Yeah, it was quite a tricky question. So let's see if we can ask you some other questions. As a physicist, and this being a conference for physicists, would you give us in some quick points how does the atmospheric dynamic work in terms of, I don't know, thermodynamics, differential equations, in terms of things we as physicists can understand, that physicists that maybe have never heard about atmospheric pollution, earth physics, and so on. If you could give us a quick insight. I don't know, maybe it's a brave question because it's too long to answer that, but I don't know if we can summarize it.
Well, of course, practically all our models are based on physical processes and understanding of physical mechanisms, and also mathematical models are based on physics. So, of course, understanding is very important. And in this case, of course, for pure physicists, what in your education, you can always apply your knowledge to atmospheric physics or meteorology. For example, by background, my university background is theoretical physics. And in the beginning also, I start working with atmospheric physics as basic physics approaches, and also moved to mathematical modeling school, and more work for many years as a modeler. And physical background of my main education as physicist helped me very much to understand the processes. Because in mathematical modeling, there is one risk that people are moving to mathematical problem and sometimes forgetting about the physical sense. It is very important to have understanding of a physical mechanism, not only just formalize into equations. So I think physical knowledge is really basic for our activities and for WMO. But you are right, what nowadays we need to consider more and more issues in interdisciplinary approach. Because our life became more and more complex, and solutions what we need to choose are also not simple and required knowledge from different disciplines. So from this point of view, this also for physicists, I think it's good what knowledge from other disciplines will be used.
So another questions. We as physicists always try look forward to the most general and abstract theory. But here when talking about the Earth system, there's a lot of different models that treat specific issues. There were a lot of models you talk about that are only useful when talking about urban climate. Then you talked about hydrology. There's a complex variety of models. So is there any prospect of finding an integrated model, as you've done? For example, you featured chemistry, and then you featured meteorology, and you did a coupled model. So is there any prospect of building a model that integrates the full ecosystem of the Earth?
Well, of course, it's theoretically it's great to include everything, but first of all, we have to be realistic, and not always our understanding is well enough to integrate. I showed one example when we included, for example, this cloud interaction into current models. Not always it leads to improvement. Because our understanding is not perfect. And of course, each specific topic, you're right, what physics is global and it's nice to describe everything. But for specific topic, we need to put efforts for understanding. When you understand the main mechanisms, we can simplify and implement into overall integrated models such kind of effects. What is the difference between science in previous centuries or decades and nowadays, in particular in physics? Nowadays, it is impossible to work individually with such complex problems like Earth system modeling and prediction, because current models include a lot of different elements which were developed during decades by hundreds, thousands of scientists. And each scientist is just contributing into such collective work with this element. But very important, what scientists is going deeper than others for specific your problem. This way how, for example, PhD studies are realized. You don't need to build model from scratch. You just develop your new novel elements and improving overall global system or integrated models. This way, what now is realizing around the world, and we are moving more and more in this direction.
Nowadays, physics is a collective task, so you can do nothing by your own.
Well, you can do by your own a lot, and contribute to global and collective efforts. But now it's practically physics is teamwork.
Because I guess you work with huge amounts of data coming from all over the world, so that cannot be you cannot deal with it individually. Mhm.
Yeah, that's right. And of course, also when data are coming from different sources, we have to be sure what such data are of good quality. So we always, for example, this Global Atmosphere Watch program, what I mentioned, it has calibration centers around the world and also data quality control. And we always work with our members to consider top level observations methods to keep high quality of data for a better understanding of the processes.
Okay, thank you very much. And now let me ask you a question for students who are planning to go into the World Meteorological Organization, or who are planning to, as you said before, a PhD in many of the different areas you mentioned along the presentation. So what are your advices for them, for not necessarily physicists, but also climate sciences from different areas?
At least as you can see from, especially I included some slides with maybe a bit boring, a long list of science topics, especially included them just to give some impulse for students. There are many issues which are waiting for your efforts, for your studies, for master or PhD, etc. If you are interested in that, and of course, always you can choose one of the topic. Of course, as we just discussed, what it is collective work, and it is important to be within a good scientific school. Difficult to do such complex research study without supervisors and research team around. So of course, in your university, it would be maybe good to contact with your professors and discuss what kind of issues are close to main trends and efforts in your university, in your departments, and look for supervisor if you are interested in specific problem and you do not see a team in your university. Maybe you can look for supervisors from other countries or other universities. And again, if some of you are interested, we can recommend some teams who are best in specific topics for research.
And based on what you told us about the CAS priorities, for example, and when you talked about aerosols, hydrology, technology techniques, so has there been any city mayor, any government, any policymaker that has listened to your studies and which implemented some kind of policy that it turned out to be very positive for the city? Is there any example of that right now?
Very good question. Of course, it is extremely important to be sure what research what we are doing is needed. This is the reason why one of the first slides of the WMO system demonstrate what we are proceeding from society needs, what is needed. And of course, from this point of view, we are looking for issues which are really needed and can be implemented later on. Fortunately for the World Meteorological Organizations, it is easy because WMO is working for our members. Members are national hydrometeorological services. And research programs which are realized internationally by all worldwide community provide recommendations for all our national members, and they are responsible for implementation and realization into practice for weather or climate forecast. But if we are going to cities, not always hydrometeorological services are responsible for such issues. So we have to work also with city governments and other type of organizations, with environmental agencies and etc. And for this specific topic, what I mentioned it about urban integrated services, we are closely working with city administrations. And recently we provided guidance for integrated urban services, where in one of the volume we demonstrate best practice of some cities. We choose about 30 cities around the world where we'll not say best, but good practice is realized. And this practice and systems can be also used by other cities around the world. Not exactly one-to-one, but at least main achievements can be utilized for their cities. And of course, from city to city, systems are different because different hazards are dominating. For example, for coastal cities, flooding is important, or for Arctic cities, other problems are dominating. And of course, it's depend of these hazards, and such system is also formulated and developed fit for purposes, what we call it.
Mm-hmm. Mm-hmm. So you were a part of the research department of the Danish Meteorological Institute, and also the deputy director of the Danish Strategic Research Center for Energy. So what experience did you get from there?
Well, it was from my private previous life before I joined WMO, and I spent
I know. As we've
16 years in the research
WMO.
department of Danish Meteorological Institute, and we had also this center. It's actually a good example of multidisciplinary research. What we call it Danish Strategic Research Center for Energy, Environment and Health. What during 6 years I was co-leading with my colleagues. The idea was to build national research center, providing optimal way for national requirements, what kind of energy production is needed, and minimize impact on climate and health and environment. And we involve 7 universities and research organizations from the country with completely different disciplines. Medical doctors, technology scientists for energy technology, climate scientists, mathematical scientists, of course, physicists, meteorologists, atmospheric pollution scientists. And first half a year, actually, we just tried to understand each other. When we understood how to connect, effectiveness of work became enormously higher. So this is one of the challenge, but it's interesting how to work multidisciplinary. Fortunately, I had experience a long time ago in International Institute for Applied System Analysis, IASA, in Austria. And it was System Analysis Institute. Main approach is linkage different disciplines. So this, I think, main experience what I got from that center, I learned how to work multidisciplinary. And of course, Danish Meteorological Institute also was a very good school because, again, even I worked in a research department, we worked very closely with operational services. So all science what we developed were realized for operational services. So we understood very well needs of users, end users, and operational community. So I think it was very good, and practically here at WMO it is also very helpful for building this chain and bridging university science with application and operational services. And it is also very important what university are collaborating with services and in particular hydrometeorological organizations. In countries where close collaboration between universities and hydrometeorological services established are the most successful, and they realize much more effective forecasting system and much more advanced. So this is, I think, the only way how to link university science, academic science, and users and applications.
Thank you very much. I've personally learned a lot about climate change and how do you cooperate and do your work, your investigation. Thank you very much. I hope our spectators have learned as well. And you know, we're reaching the top hour, so we'll leave it here.
Okay.
Wish you the best of lucks with your investigations.
Thank you very much, and good luck for all of you and for physical students to choose the right area of your research and activities useful for the society. And I hope some of you at least will choose meteorology and climate research. All the best, and thank you for the attention.
Thank you. And this was IAPS, a distance session on environmental physics. This was the last one from from these weeks. So we'll leave it here, and we hope to see you soon in more IAPS 7s. So bye.